All right, let's continue this little physical science practice with looking at a two-dimensional case. So we're going to do locate the center of mass of a very simple two-dimensional system. But I need to build up the concept a little bit before I break out the calculus of this. So here is our point with coordinates 2, 5. And let's just say that this point has a mass concentrated there of 7. Now, when we look at our moments, we're going to actually have two of them. One will be the moment related to what's going on left and right with respect to the y-axis. The moment about the y-axis, we would call that. Well, the y-axis separates our left and right side, and this point is located 2 units to the right of the y-axis. So its moment around the y-axis is actually its x-coordinate multiplied by the mass, because that's 2 units to the right of the y-axis. So that would be 2 times 7, which would be 14. A positive number, which means to the right of the y-axis, is where it's tending to. Similarly, the x-axis, this point is above the x-axis, and it is 5 units above the x-axis. It's actually the y value that tells you how far away you are from the x-axis. And its moment about the x-axis is 5 multiplied by the same mass of 7, which is 35. Again, it's positive, which means it's in the positive part of the above the x-axis. Now, the concept is, if there were multiple points and multiple masses, we would want to calculate these moments by summing up all of the possible combinations of individual moments. So around the y-axis, if you get something positive in this sum, that means it's whatever this shape looks like, the center is to the right of the y-axis. So we'll take all of the individual x values multiplied by their masses, and this would be sort of our short, simple little formula for saying if there are multiple points, this is how we'll do the calculation. And if we're looking at the x-axis as the point of line of rotation, then the y values above or below will tell you if you're above or below where your center of mass will be eventually. So we'll sum up all the y values multiplied by their masses. I know the symbols look a little bit opposite of each other, but remember, y equals 5 is a horizontal line that is 5 units above the ground. It runs left and right. The y-axis itself is separating the left and right side, so that's what we're focusing on here. So let's add a second point to our system here. How about a point here at -3, 1, and let's have it with a mass of 4 units that are not specified here. So when I attempt to calculate the moment about the y-axis, I'll take each x value times its mass, -12 and 14 would be 2. And when I look at the same with the moment about the x-axis, we'll take each y value multiplied by its mass, and we'll total them up. (39). And these both being positive values means eventually our center of mass is going to be somewhere where both x and y are positive. this quadrant here. But first we need our mass. And mass would just be the sum of all the individual masses, which for this problem is just 4 plus 7, which is 11. So our center of mass for this problem in 2 dimensions, x bar, y bar, basically separately calculated. We will take our moment left and right, which is the moment about the y-axis, divided by the total mass, and the moment above and below, which is the moment about the x-axis divided by the mass. And for this particular problem, what does that get us? It gets us 2 divided by 11 and 39 divided by 11. 2/11 is just slightly to the right of the y-axis. And this is a little bit more than 3 units, about 3.5 units up. So right here, about here, somewhere around here, we would find our center of mass for this system. A little bit to the right, about 3.5 units up. Somewhere around here would be our center of mass, balancing those 2 points, their masses. All right, calculus part comes next.